So for today's lesson, integration by parts, we are going to look at how to undo product rule and quotient rule. The easiest way to identify when we will use this method is when you see your expressions having a product of two pieces, where you cannot differentiate one of them and give us the other part here. Like what I show you on the whiteboard, if one part of your expressions cannot be obtained using the other one, then we will go with integration by parts. And here is how we can come up with that formula. First of all, we are going to look at how the product rule were developed and try to undo it. So a few classes ago, when we were trying to differentiate something that involved a product, we will differentiate one part at a time. We cannot differentiate both the first part and the second part altogether. We need to differentiate one part at a time. So in this example, I've differentiated the second part first and then the first part of the expression. And as you remove the denominator, this is what you will see for the second step. And that means when you try to integrate something that looks like this, it will be the same as integrating the right hand side this way. But we know that the integration here and the differentiation there are simply a reverse operation. Integration and differentiation are opposite to each other. So they kind of cancel each other out, and that means if you end up with something that will involve the multiplication of two pieces, it will be the same as integrating the right hand side this way. So by rearranging your expressions, if we can let u be something and dv be another part of your integration, we can always integrate expressions like this using the equation here. Now for now it may seem a little bit abstract, but once we start to use some example, you will start to see how this formula can be applied. So here in example number 1, if I want to integrate the product of this and that, x times cosine x, pretty obvious, you cannot use substitution to obtain cosine x from your x, or you cannot obtain the x from your cosine x. So we are going to split this up into two parts. Here, I will let u be something that is easy to differentiate. Because once you differentiate something easy, you can consider that to be your du. We are going to let the second part to be something that we can integrate easily. So in example number 1, I'm going to let u be x and dv be the rest. So we are trying to integrate u. We try to express the questions here in this way. And by doing this, we can figure out the du and the v. We can differentiate the u here to get dx, and then as you integrate your dv, as you integrate the left-hand side of this, you will be integrating the right-hand side, turning it into sine x. Once we've obtained the u, the v, the du, and the dv, we can now make use of the equation, make use of the formula from the above, and have u times v minus the integration of v times du. Well, technically, du equals dx for now. And as you can see, we can integrate sine x relatively easy. Integrating sine x will give us negative cosine x, and with a minus in front of it, it will be the same as plus cos x. If you try to differentiate these expressions, you will actually come up with x cos x at the end. Let me differentiate this. If I try to differentiate x sine x plus cos x, using your product rule, the first part will give us this. And then differentiating your cosine x, it will give us negative sine x. And sine x and negative cosine x will actually cancel each other out, giving us x cos x at the end. So using this magic formula, you will be able to integrate something that is not easy to integrate at the beginning. Once you know you cannot apply a u substitution for your integral, we will go with integration by parts right away.